Good morning. We are students from SSN College of Engineering and we do BE Biomedical Engineering. With regard to the NI Yantra project 2011, the shown VI is our initial efforts towards the project competition. And our project title is Development and Implementation of Electrooculography based assist devices. This shown simulated VI shows the acquisition of the EOG component signal. That is, this component signal denotes the eye movements in the right and left directions. That is, for the right and left directions we have a peak and valley. Similarly, we acquire the blink component of the EOG signal. In this VI, the prime objective would be to bring about cursor movements in the right and left directions as per the directional gaze in the respective directions by the subject, and when the subject blinks, the folder gets selected. That is, to manually show when the person gazes in the right, there will be a folder movement in the right direction, and when the person blinks, the folder gets selected. That is, the picture gets selected. I have shown this currently using manual key press direction. I will be showing it the same output would be occurring when I run the VI. So before running the VI, the user can select the respective folder and leave it covering the off screen, so that the remainder part of the screen can be covered by the EOG component signal lab view window, so that it will be easy to visualize the changes. So currently the mouse cursor is here. So once the setup has been finished, we can run the VI. Now before that, I will brief about the thresholds that has been currently employed. We employ a left and right threshold and we have a blink threshold. It's to be noted that in this VI we don't employ a right and we don't employ a vertical key direction. Vertical to direct movement in the vertical direction. That is, we didn't include the vertical component of the EOG signal, since it is an initial effort which has been done in our currently developed VI, which we haven't mailed it yet. We'll be mailing it soon, as providing with certain other updates of our project. And also the vertical signal, it looks similar to this signal, and with the peak for up direction and a valley for gaze in the downward direction. So this VI will deal with movements in the left and right directions and the folder selection by blink action. So let's run the VI. As you can see, threshold will activate right only for this component of the EOG signal. Since I have set the threshold to 5500, it will be activated only for right signal and will be seeing the right glowing up here. And similarly for left, it will be activating for this signal since the threshold has crossed. For a left, and there won't be any right signal now, as the threshold has not been crossed by that signal. There won't be any right signal because I have set it for 5500. Similarly for left, it's minus 3000. And now for this blink pulse, we have a 2500 threshold, and it has been, and this pulse has crossed the threshold. Hence there will be a blink action that has been performed. Hence we can open the VI. So we place the cursor here. As you can see, the person has gazed towards his left, and towards his right, the cursor has moved towards his left. And now there will be a blink action, so that the person has selected the picture and it has been opened. And similarly for the next cycle, there will be a movement in the right direction. As you can see the right pulse here, there will be a movement in the right direction. There's a movement. and similarly for the left next consecutive pulse there will be a movement in the left direction. And now there's a blink pulse, so the picture gets altered. So this is how the entire VI works, but it'd be very easy to visualize the changes in a real-time scenario. Since it is a simulated output, it'll be difficult to visualize the changes. But if it has been a real-time video, I've included the real-time video in the sent mail, where it'll be easy to visualize the changes as the person does the respective direction. Does the movements in the respective direction. Also, in this VI, we have employed threshold detectors. So that's why the threshold detectors is implied by the comparators here. It's for up and down comparator for the left and the right direction. We have employed comparators here. So that's why there's an abrupt transition when the person gazes towards the right. Say for a person, if the person gazes towards the right, there will be an abrupt transition across the entire stretch. It'll be a stretch across the entire screen. It won't be a one-to-one transition as shown here. So that is to say, to convert this into a single pulse, we have removed the threshold detector, and instead of that we have employed a peak detector in our currently developed VI, so that when the person gazes towards his right direction, there will be only one transition, not an entire stretch transition as shown when the VI was running. And when the person is blinking towards his left, there will be only one transition. That is to say, for this one right pulse, there will be only one trigger pulse which will be sent to the DLL function, and towards his left pulse, there will be only one trigger pulse which will be sent to the DLL function. So that the event will occur only once, and this has been done efficiently in our currently developed system, system VI, and we have also included the vertical component signal there. So we will be mailing the next VI with the updated changes as indicated in our report, and we have completed the software part of it, and we are yet to embed the entire code into a standalone system. This project requires a computer, as it is a human computer interaction project. It requires a computer for the same. Thank you.